Welcome to Mr. Soul Tutorial channel. In this video, we will be considering the interconnected system, which are majorly the data connected system and the star connected system. These systems are used in the transformer and can also be used in the industry. It is of importance for us to know how to convert from one system to the other. But in this video, we are going to be seeing how to convert or to transform from delta to star, which is from delta to star, which is also known as a delta star transformation. Basically before now, if we have two resistance in parallel that is connected head to head, that is to say we have R1 and R2 connected head to head. This is called a parallel system, which we would have done in the previous videos. So for us to find the total resistance at terminal AB, mean that our total resistance RAB, that is the resistance at this point, RAB is given as, because this man is connected head to head, which is a parallel connection, be given as R1 R2 divided by R1 plus R2. Yes. Now we have specified that these resistances are connected in parallel. But in the interconnected system, you have seen that this resistance is either connected in parallel or connected in series. How the use of it? That is why the delta to star and star to delta transformation or conversion system was coined. So let us consider how to convert from delta to a star network. Now, in this network, to start, these are a terminal. Call this terminal 1, call this terminal 2, call this terminal 3. Alright? Pretty cool. Now, this circuit is flowing in a clockwise direction, as you always say. That is to say, we will follow it like this. Mean that this resistor here is going to be resistor R1, 2. That is R from 1 to 2. Right? That's pretty cool. While this one is resistor R2, 3. R from 2 to 3. The last one is resistor R3, 1. Now, what I'm going to show you is a simple approach of transforming from delta to star. So now, what we are having in mind is for us to have this system to be in this form. Note that I'm using the dotted line in the middle. Take note of that. That's what we are having in mind. What we are having in mind is for us to have a resistance that in this form, which is this form. So now, it's worthy of note for you to know that one next you have to do. Look at this middle resistance here in the star connection. It's connected to point 1. You call this R1. Clear? Look at this one that is connected to here. It's connected to point 2. Call this R2. And this one is connected to point 3. Call this R3. So we can boldly say that our transformation from this delta will give us a corresponding value in this star as R1, R2, and R3, numbering them in a clockwise direction. This value of R12, R23, and R31 will be given. What you are going to look for is the corresponding value of that in the star connection. So, for us to find the R1, looking at this system now, you can see that this R1 is lying between R12 and R31. So now therefore R1 will give you, this is a shortcut method of solving this. R1 will give you R12, which is in between, times R31, correct? Divided by the sum of all the resistance, that is sum of this R12 plus this R23 plus this R31. That will give the value for R1, which is this value. See clear? Now the value for R2 we given. Looking at R2 here, you can see that this R2 is lying between R12 and R23. So it means that our R2 will be given by R21 times R12 times R23. That is R12 times R23 divided by the total sum of resistance, which are R12 plus R123 plus R31. Right. In the same way, looking for R3 now, R3 be given by R3 is lying between R31 and R23. So you're going to give you R23 times R31 divided by the sum of the resistances, which are R12 plus R23 plus R31. This value will give you the value of the corresponding resistance in the star connection in home. Let's consider this problem that says determine the resistance across the terminal AB of the interconnected resistor in the figure below. Now in this problem, we are going to consider this circuit as shown below. We have seen that this is a delta connected part and this also is a delta connected part. So you can choose to take any of them to make life easy for us. Let's take the upper side. If you are considering this part to be the delta connected side, that is to say, what we are looking at is for us to have a corresponding star network like this. Right? Yes. So it's worthy of note for convenience sake to always label these terminals so that you can be able to carry out your calculation. So you can call this terminal 1, call this terminal 2, and this terminal 3. When you're considering this part, you can call this your R23, this is your R12, this is your R32, flowing this way. So at this point, taking our R12 will be equals to 6 ohm, which is here. Our R23 to be equals to 6 ohm, which is here. And our R31, which is equal to 6 ohm, which is here. Recall previously what we did. We're going to use this formula that we derived. And this formula, in this formula, we can see that our R1 is given by R12 times R. So it means our R1 is equals to 6 times 6 divided by the sum of all the resistance, which are this resistance in this part, which is 6 plus 6 plus 6. This will give us 6 times 6 is 36, divided by 6 plus 2 will give us 18. 30 divided by 18 will give us 2 ohm. That, and our R2 from this formula is given by this formula, which is our R12 times our R23 divided by some resistances. This is our R2, right? Yes, this times this divided by some of this will give you 6 times 6 divided by 6 plus 6 plus 6 will give you the same thing, 36 divided by 18. The value of resistances might change, but in this question they're giving the same value of resistances. our R3 is given as this our R3. This opposite this time this divided by total sum. Give you 6 times 6 divided by 6 plus 6 plus 6 is equal to 36 over 18 equal to same 2 ohm. Yes, that's pretty cool. Now having have this value of resistances, we now put the values into this circuit, withdrawing the circuit again using this star instead of this delta. Use this star. So withdrawing the circuit now, we're going to have something of this nature. We're going to have something of this nature. Quickly, we'll have something like this, 2 ohm, something like this, 4 ohm, something like this. This is R2, which is equal to 2 ohm, for R1, which is equal to 2 ohm from what we calculated here, and our R3, which is equal to 2 ohm. So having seen this, you can see that this is another network entirely, terminal A and terminal B. Yeah, having seen this, you can see that these two men are in series and these men too are in series, right, parallel to each other. You're going to say because this and this are in series, you're going to say 2 plus 2 give us 4, 2 plus 4 give us 6. So you're going to have something like this at the end. This two one is in series, this 2 ohm is in series like this, that is 2 ohm, something like this, plus this is parallel connection. This plus this give us 4 ohm. This plus this will give us 6, give us 6 ohm resistance connected in parallel like this, of this nature, right? Yeah. We're gonna have as this that we are having that from here. You see that this one and this one are connected in head to tail in series. This is the same thing as head to tail in series, giving us a parallel connection like this, head to head like this. Seeing that R4 ohm producer is parallel to 6, which is given by 4 times 6 divided by 4 plus 6. This is gonna give you 24 over 10, which will give you 2.4. Mean that what we have here, this parallel resistance is given as 2.4. So we're going to have finally that R2 is in series, that's R2 plus 2.4, because these two may return to one series 2.4. Therefore our total resistance at terminal AB given by 2 plus 2.4, which equals to 4.4 ohm at the value of resistance. Thank you very much for watching. Please do well to subscribe to our channel as more videos will come your way. Our next video is going to be how to convert from star back to delta. Thank you very much.